we need to integrate sine t to the fifth over the square root of cosine of t dt. And these problems were always pretty difficult for me, and what I like to do as my first step is just kind of take a step back and look at how they can be manipulated, where you'd be able to use your trig identities and things of that nature. And since we have an odd power on the sine, we can take one of them out, as you'll see, and that's going to allow us to use our trig identities. So this can be rewritten as the integral of sine squared t, quantity squared, over square root of cosine of t times sine t dt. So this is going to be able to be substituted for 1 minus cosine squared. If you remember, sine squared plus cosine squared equals 1. Therefore, sine squared equals 1 minus cosine squared. And so that's a good thing. And we just took out this sine t. Now, we just need to get rid of this sine t somehow. And that's where our u substitution comes in. So for u, I'm going to use cosine t. And I knew to use cosine t because the derivative of that is negative sine t, which is going to get rid of this sine t right here in our equation. So I'm actually going to just take this negative out to the du and make that sine t. Now we can rewrite our equation, the integral sine squared t quantity squared over cosine t, square root of cosine t, and since du equals sine t, we can just plug that in. Don't forget this negative, we're going to keep it on the outside of the integral and plug in du. Now let's make everything in terms of u, since we're integrating in terms of u. This is going to be the negative integral of, remember that this sine t, using this formula, can be rewritten as 1 minus cosine squared, which would be 1 minus u squared in terms of our u substitution, quantity squared, over u to the 1/2 du. And we need to FOIL this out. So that equals the negative integral of 1 minus 2u squared plus u to the 4th all over u to the 1/2 du. And then if you just simply divide the top by the bottom, that will give us the negative integral. Don't forget that negative. The negative integral of u to the negative 1/2 minus 2u to 3/2 plus u to the 7/2 du. And from here, it's just simple integration. Don't forget the negative on the outside. We have 2u to the 1/2 minus 2u to the 5/2 times 2/5 plus u to the 9/2 times 2/9. And this is an indefinite integral, so we're going to need to add c. And simplifying this would just be negative 2u to the 1/2 minus 4/5 times u to the 5/2 plus 2/9 u to the 9/2 plus c, distributing that negative 2u to the 1/2 plus 4/5 u to the 5/2 minus 2/9 u to the 9/2 plus c. And all we need to do now is plug in our u back into the equation to get our our final answer in terms of t, which is what we were given in the beginning. So the final answer is going to be -2 cosine of t to the 1/2 plus 4/5 cosine t to the 5/2 minus 2/9 cosine t to the 9/2 times 2/9 plus c.